Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. We have been discussing alkene alkyne metathesis in the past few lectures. In particular, we have looked at various types of alkene alkyne metathesis reactions which are known. We have also looked at the mechanism, possible pathways that are that have been proposed for this alkene alkyne metathesis mechanism. What we had noted is the fact that these alkene alkyne metathesis mechanism reactions are usually done under high dilution conditions, where these alkene alkyne metathesis or enine metathesis are performed on substrates containing double bond and triple bond in a intramolecular fashion, whereby minimizing the secondary reactions like cross alkene and cross alkyne metathesis reactions. We have also seen that in these alkene alkyne metathesis reactions or enine reactions, the most popular view is of the fact that this enine metathesis reaction proceeds with alkene getting metathesis first, followed by the alkyne, which leads to a singular or more regioselective products, whereas if the possibility for the other mechanism, which is alkyne first mechanism, would lead to various regioisomers, which have also been explained. And we had also seen in the previous lecture that utility of utilizing ethylene C2H4 in carrying out this enine metathesis reaction helps in increasing the catalyst active species concentration and also reducing their resting state time. So, with that we move into today's lecture, where we are going to take a look at some of the examples of this alkene alkyne metathesis reaction. And the reaction is given for the substrate which has a carbene catalyst. Now, the possibility of this reaction happening can give rise to two types of products, which we are going to sort of disclose as we say. So, proceeding along the first in first strategy, so that would imply this reacting with CH2 would give a cyclobutane intermediate like the one shown. Would give the corresponding carbene active species plus ethylene. Now, this then would react with acetylene, maybe in first scenario it would be this is R2 and R1 would give the species R1 and then subsequent rearrangement would give R2 double bond this R1 this product, whereas the other possibility which is possibility 2 of R2 this reacting with R1 in this conformation would give the corresponding species that would again undergo a rearrangement the way it is shown R2 R1 maybe the way it is shown, do it with proper color of the ink, R2 R1 this and this reacting with again the CHR2 would give plus R1 and similarly in the parent case this reacting with would give R2 R1 this. So, what can be seen that there is a possibility of two kinds of products coming out of it. One which is shown over here, where this R1 and R2 or R2 is in cis conformation to each other, and the other possibility is this where these R1 and R2 are away from each other. So, these are the two possibilities which emerge, and this arises primarily due to the two different orientation of this active catalyst reacting with the alkyne, as is shown over here. This leads to two different product. Of these, the one which is favored is this is favored, and mainly because of sterics reasons, where these R1 R2 are spread far apart. Now, in this mechanism, what I had done, I had just carried out the in first. This is a in first mechanism. That means the first is metathesis between the alkene and the active species, and then the metathesis between the active species and the alkyne. So, in the in first mechanism, the pathway that I had shown is of one type. There exists another orientation as well, which I will draw it right now. And this will thus give this will thus give the product which is shown over here. So, the point to note that this pathway does not go any further, because these active species and the starting active species are the same, and this kind of orientation does not lead to the product. So, to sum up, in this in first strategy, the reaction proceeds by the mechanism which is shown over here, and I am going to separate this . In the two pathways, I am going to separate this as the one in the brown, which is what is the favored product. So, this is how the reaction proceeds, and there are other possibilities are also outlined. And so, this was a nice demonstration of the in first mechanism that we had spoken about, and we are going to take a look at some more examples during the course of this talk, where we are going to see some other examples where such in mechanism indeed occur. So, similarly, so in this case as well, the reaction is between TBSO, this alkene OTS in presence of metal carbene catalyst, and this can also be worked out as is shown here. So, this will start with the olefin and reacting with this giving the metallocyclobutane that will undergo rearrangement as shown to give and an olefin which is nothing but ethylene. Now, this would react with the alkyne substrate OTS in the orientation shown here, to give TBSO OTS that would undergo giving TBSO OTS, and then this reacting with Cr2 CH2 would give the olefin that would on reaction with ethylene would give and the desired product as is shown. So, this is the product uh, which is formed from the reaction of TBSO vinyl olefin with the acetylene as is shown over here. Some more examples along the similar fashion would be seen in this slide. In wine metathesis examples, and this is between the reaction between bromide, TMS, O acetate with a metal carbene complex as the catalyst, and this can be worked out in a similar fashion as is shown. This with would go through this intermediate to give the metallobromo cyclobutane intermediate that then would undergo rearrangement to give the ethylene as the side product and as the active species, which would then undergo the reaction with TMS OAC and also undergo rearrangement as is the way shown over here. OSC. So, this would undergo rearrangement as is shown, and this would mean that Br OAC TMS M and this reaction with olefin would give back and TMS OAC. Now, there is another possibility that also exists in this case, which is shown over here, this reacting with TMS OAC, and that would also undergo rearrangement as is shown here. Would give intermediate like this, TMS, and this would subsequently give the product TMS. OAC, and that upon reaction with C2 H2 would eliminate metal carbene to give the product TMS. So, what we saw is that depending upon the orientation, of the alkene and the olefin, two different kinds of products are obtained. One is this, the other is this, and of the two orientations, what has been observed is the ones which are sterically stable is the one which is favored, and this product is the favored product for this transformation. So, regio and stereoselective synthesis, this is both regio and stereoselective synthesis. So, with this we come to the end of today's lecture, where we had taken 3 examples of these E9 metathesis examples, and all of them has been worked out with in first pathways where the active species reacts with the olefin, and then in today's lecture we have worked out at the different pathways arising from the orientation of the carbene metal complex and the alkyne, and depending on the different orientation different products were formed, and these the product ratio is mainly guided by the sterics. So, one which gives the minimum steric hindrance is the one which predominates in the end. So, we are with this we come to an end on today's discussion of E9 metathesis examples, and we are going to take up this reaction in bit more detail and few more examples as we discuss E9 metathesis reaction in the next class. Till then, thank you for being with me, and hope to see you in the next class. Goodbye.